Okay, good afternoon, everyone. In the beginning of the class, let us see new announcements. Okay. The first new announcement is March 31st, 2022 videos uploaded, make up lessons. Hello everyone, I have uploaded the make up lessons videos for March 31st, 2022 to YouTube. The lengths and URLs of the videos are Part 1, length 25 minutes 7 seconds. URL is this. Part 2, length 25 minutes 14 seconds, and the URL is this. Part 3, length 25 minutes 9 seconds, and the URL is this. Best regards, Wei Zhen Liu. Okay, the second new announcement is the slides of chapter 2 has been updated. Version 2022-0407. Hello everyone, I have uploaded the newest version of slides of chapter 2 to eCourse2 website. The location and the file name are eCourse2 website, wireless communications and machine learning. Course content, slides, chapter 2, reinforcement, learning. Okay, learning for resource allocation in cognitive radio networks. Slides 2022-0407.pdf. Best regards, Wei Zhen Liu. Okay, the third new announcement is the handout of chapter 2 has been updated. Version 2022-0407. Hello everyone. I have uploaded the newest version of handout of chapter 2 to eCourse2 website. The location and the file name are eCourse2 website, wireless communications and machine learning. Course content, handouts, chapter 2, reinforcement, learning for resource allocation in cognitive radio networks, handout 2022-0407.pdf. Best regards, Wei Zhen Liu. Okay, so that's all. Next, let us look at the progress of the last class. Okay, in the last class, we have taught to chapter 2, slides, page 21, a very important question. Okay, please open the slides, okay, of chapter 2. And please turn to page 21. Okay, page 21. Okay, so after reading this page, you need to ask yourself a very important question. Okay, let us see the blackboard. Okay, I need to open the file, okay, with Word. Okay, because we do not have a blackboard now, so I use the Microsoft Word instead. Okay, chapter 2, page 21. Problem 1, who subject, interfere, who object. Okay, let us see how to find out the solution. Okay, in the denominator, we can see that the first term and the second term are interference power, and the third term is the noise power. And for the first term, G0S is the channel gain from the primary user to the secondary base station. So the primary user is the subject, and secondary base station is the object. Okay, let us go to the blackboard. Okay, so subject is the primary user, and the object is the secondary base station. Okay, but please note that we have another interference power term, that is the second term in the denominator. Summation I is equal to 1 to capital N. Okay, where capital N is the number of secondary users, and GIS is the channel gain from secondary user I to the secondary base station. So we can know that all secondary users are also the subject. So let us go back to the blackboard. Okay, so all secondary users are also the subject. Okay, next you also need to ask yourself a very important problem. What is the communication direction? Uplink, downlink, or both? Okay, let us go to the slides. Okay, in the numerator, we can see that this term is the signal power. Okay, and the GIS is the channel gain from secondary user I to the secondary base station. Okay, because the direction is from the secondary user, that is a mobile user, to the secondary base station. So we know that the communication direction is uplink. So please go. Let us go to blackboard. So solution is uplink. Okay. Okay, let us go back to the slides and turn to page 22. Assuming that the transmission achieves the performance given by Shannon's channel capacity, we can express the primary user throughput as, okay, what is the throughput? Let us see. Okay, what is the throughput? Okay, please open the handout of chapter 2. Okay, and search for throughput. Oh, okay, throughput. Okay, page 22. Problem 1. What is throughput? Solution. In communication networks, network throughput, or just throughput when in context, is the rate of successful message delivery over a communication channel such as Ethernet. Okay, we will explain. I will explain what is Ethernet in problem 2, or packet radio. I will explain what is packet radio in problem 3. Okay, problem 2. What is Ethernet? Solution. Ethernet is a family of wired computer networking technologies commonly used in local area networks (LAN), metropolitan area networks (MAN), and wide area networks (WAN). Okay, So now you do not need know the definition of len, men, and when, because I think it is too detailed. Okay, so we do not. I do not plan to explain these three terminology here. Okay, please see figures 6 and 7. Okay, figure 6 is this figure. Okay, we can see there is a twisted pair cable. Okay, this cable with an 8P8C modular connector. Okay, this is the 8P8C modular connector. Okay, what is the 8P8C modular connector? Okay, I think we do not need to know it now. Okay, or we will spend much time to explain the details. Attached to a laptop computer used for Ethernet. Okay, this is the laptop computer. Okay, next let us see figure 7. Okay, this is an Ethernet over twisted pair port. Okay. Okay, I believe you have seen this. For example, in your lab. Okay, you can see many these ports on the wall. Okay, let us go back to Ethernet. Okay. And problem 3, what is packet radio? Solution: packet radio is a digital radio communications method used to send packets of data. Okay, please see figure 8. Okay, before we see the figure 8, usually if we mention the word radio in telecommunications, it often means the wireless communication. Okay, this is figure 8. This is a terminal node controller, that is TNC. It is the abbreviation 2400 packet radio modem. Okay, what is modem? The modem is composed by two words, that is the modulator and demodulator. So the first two letters of the word modulator is MO, and the first three elements of the word demodulator is DEM. Okay. Okay, let us go back to the packet radio. Okay. Okay, here. Okay, now let us go back to the slides. Okay. So throughput as R0P, which is equal to W, where W is the channel bandwidth, times log 2 of 1 plus gamma 0 P. Okay, what is gamma 0 P? Okay, it was defined in equation 2.1. Okay, it is the signal to interference plus noise ratio (SINR) of the primary user, and is equal to this equation. Okay, and that of a secondary user I. Okay, what is that? That means the throughput. So the throughput of secondary user I, whether 1 is smaller than or equal to I, and I is smaller than or equal to capital NS. Ri of S is equal to W, okay, where W is the channel bandwidth, times log 2 1 plus gamma IS. Okay, what is the gamma IS mean? Okay, gamma IS is equal to this equation. And gamma S is the corresponding SINR for secondary user I. Okay, so we can know that the Shannon's channel capacity is equal to the bandwidth times log 2 1 plus SINR. Okay, conventionally, from the perspective of a single secondary user I, when transmitting real-time multimedia traffic, for example, videos. Okay, for example, if I am using my cell phone to watch a YouTube video, okay, then the base station is transmitting a real-time multimedia traffic to my cell phone. Okay, so the link performance, the link, is the communication link from the transmitter to the receiver. Okay, the link performance can be objectively. Okay, what is objectively? Now let us see the handout. Okay, problem 4. What is objectively? Solution: in a way that is based on facts and not influenced by personal beliefs or feelings. Okay, let us go back to the slides. Objectively measured at the application layer. Okay, what is the application layer? Let us see the handout. Okay, problem 5. What is an application layer? Solution: an application layer is an abstraction layer that specifies the shared communications protocols and interface methods used by hosts in a communications network. Please see figure 9. Okay, figure 9 is the application layer in the 7-layer OSI model. Okay, we have introduced the OSI model before. Okay, we know that there are 7 layers in the OSI model. The layer 1 is physical layer. Layer 2 is data link layer. Layer 3 is network layer. Layer 4 is transport layer. Layer 5 is session layer. Layer 6 is presentation layer. Layer 7 is application layer, which is the topmost layer. Okay, and the physical layer is in the bottom layer. So these 3 layers, session layer, presentation layer, and application layer, control the application data and information. Okay, let us go back to the slides. Okay, application layer by the expected end-to-end distortion denoted as DI. Okay, what is end-to-end distortion? Let us see the handout. Okay, let me search. Okay, end to end. Okay. Okay, problem 6. What is the end-to-end distortion? Okay, solution. The end-to-end distortion comprises the source encoder distortion, Okay, I will explain what is source encoder distortion in problem 7, which depends on the source encoding rate. Okay, I will explain what is source encoding rate in problem 8. And the channel induced distortion, which depends on the channel SNR, use of cooperation. Okay, the use of cooperation means the cooperative communications, which is a kind of cooperation among the users. Channel coding rate. Okay, I will explain what is channel coding rate in problem 9. And error concealment. Okay, I will explain what is error concealment in problem 10. Okay, let us go back to the go back to here. So problem 7, what is source encoder distortion? Solution. Source coding is a mapping from a sequence of symbols from an information source to a sequence of alphabet symbols, usually bits, such that the source symbols can be exactly recovered from the binary bits or lossless source coding, or recovered within some distortion, lossy source coding. This is the concept behind data compression. Okay, problem 8. What is source encoding rate? Solution. I have tried to find the definition of source encoding rate by using Google for a long time, but I still cannot find the answer. Okay, I will continue to find the answer. After I find the answer, I will type the answer here. Okay. Okay, problem 9. What is channel coding rate? Solution. Channel coding rate is defined as the number of information bits per coded channel symbol. Okay, problem 10. What is error concealment? Solution. Error concealment is a technique used in signal processing that aims to minimize the deterioration. Okay, I will explain what is deterioration in problem 11. Of signals caused by missing data called packet loss. Okay, I will explain what is packet loss in problem 12. Okay, problem 11. What is deterioration? Okay, solution: to become worse. Problem 12. What is packet loss? Solution: packet loss occurs when one or more packets of data traveling across a computer network fail to reach their destination. Okay, let us go back to the slides. Okay, so we have explained what is the end-to-end distortion, denoted as DI. Being an end-to-end matrix, the expected distortion DI is composed of two components: a source encoding distortion, okay, which we have explained in the handout, DIS, and a channel-induced distortion, DIC. Okay, what is channel-induced distortion? It is the distortion caused by the channel. Okay, please see Kwasinski and Liu, 2008. Okay, it is 25 minutes. Let us take a break.